In the most recent video, I discussed the similarity between the Navier-Stokes equations and the Lorentz force law, which describe hydrodynamics and electrodynamics respectively. In this video, I will discuss why this similarity exists. The gravitational and electromagnetic interactions are those that have the clearest physical effect on the events that occur throughout the days on Earth, especially gravitational and electromagnetic attraction. They are observed in water systems and electrical lines, blood vessels and nerves, and many other phenomena. Why is this? By understanding them through the symmetry between the physical and the geometrical aspects of existence, we have a clear answer. Let's consider a two-dimensional space. What are the motions in this space? There are two spatial principal axes, the horizontal and the vertical. The duality of motion of the particle along either axis corresponds with the influence felt by a positive charge on another positive charge, and vice versa when they repel, or the influence felt by a negative charge on another negative charge, and vice versa when they repel. The horizontal axis is symmetrical with the positive charges, and the vertical axis is symmetrical with the negative charges. When we mix the two spatial principal axes, we get rotation. We can rotate clockwise or counterclockwise. Switching the order of the arm in the motion vector switches from counterclockwise to clockwise. This is symmetrical with the attractive influence from a negative charge on a positive charge in one case, clockwise, and the attractive influence from a positive charge on a negative charge in the other case, counterclockwise. If we switch the direction of the axes for both axes, the order of the arm in the motion vector for counterclockwise and clockwise is the same. If we switch to the negative axis for one axis, the order of the arm in the motion vector for counterclockwise and clockwise is different. Let's consider a zero-dimensional space. What is the motion of this space? A zero-dimensional space is the particle itself, but it doesn't translate or rotate. It can remain stationary, however, and change orientation and time, as the single axis rotates, effectively a zero-dimensional rotation. The one spatial axis that rotates has two directions, forwards or backwards. When there was a rotation in two dimensions, when one axis changed direction, the motion always switched from clockwise to counterclockwise or vice versa. Two axes cannot change direction since there is only one axis, so we do get a switch from clockwise to counterclockwise with any change in direction in this case. So for this zero-dimensional rotation, we can treat the one axis changing direction as switching from clockwise to counterclockwise. Gravitation arises from the curvature of spacetime, which is essentially the attraction of points in a vacuum to other points. A vacuum is zero-dimensional matter because by itself it has no mass. Just as zero-dimensional matter or space can attract itself, a zero-dimensional space or a particle of matter can rotate about itself. The gravitational attraction corresponds to the zero-dimensional rotation as electromagnetic attraction corresponds to the normal two-dimensional rotation, with two spatial axes being symmetric with the two material axes of positiveness and negativeness. The gravitational pull of a mass on another mass and vice versa is symmetrical with a clockwise or counterclockwise rotation that results from the choice of which side of the single spatial axis corresponding with the single material axis of heaviness for mass is involved in the rotation. This is precisely the difference between the gravitational and electromagnetic attraction that occur constantly on Earth. There is a symmetry between zero-dimensional geometry and zero-dimensional physics, gravitation, as well as between two-dimensional geometry and two-dimensional physics, electromagnetism. Next time you ask yourself why there is a difference between gravitational attraction and electromagnetic attraction, the answer you should remember is that there is a difference between the rotation of a point about itself in a zero-dimensional space involving one axis, and a rotation of a point in two-dimensional space involving a radius and a tangent to the curve of rotation, or two axes.